Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. Everyone, my name is Anthony Nathaniel, and in this particular episode of our class mathematics for SS3, we are going to be dealing with a detailed method of how to plot your graphs from your quadratic equations, and again how to get your quadratic equation when you have plotted a graph, and so on. So it is like plotting a graph from equations and plotting and getting equations from plotted graphs. So I want you to pay attention very carefully because this episode is going to be packed with a lot of wonderful information, and hopefully you are going to enjoy this video. Don't forget to like, share and subscribe so that you can promote me to begin to continue to provide educational content like this. So without wasting much time, let's delve into the question. Now I will be explaining this with the use of a question, and then I'll be practicalizing it with my hand. I'll be drawing the graph on a graph paper. So now we're asked to draw the graph of y equals x squared plus x minus 5 for values of x ranging from -4 to +3. Then we are using a scale of 1 centimeter to 1 unit on both axes. So now what this means is that you are plotting this graph of y equals x squared plus x minus 5, and then you are plotting from the range of -4 to +3, and then you are using a scale of 1 centimeter to 1 unit on both axes. So you are using a scale of 1 centimeter to 1 unit on both the x and the y axis. Now I will show this is the table of the values. So the table of values range for the value of x minus 4 to -3 to -2 to -1 to 0 to 1 to 2 to 3. That it ranges from -4 to 3, and then you are going to have the corresponding values of y. So if you watch the SS3 episode, I've talked about graphs in that episode where we talk about how to plot these graphs from different equations, and then you make use of the values in the equation. For example, when y is equal to x squared plus x minus 5, you create a row for x squared. So you create a row for x. So after evaluating x, you evaluate x squared, then you evaluate x, you evaluate -5. So when you add each entry, each relevant entry for the columns, you get the columnar value of y. So for the next column you get the column values of y, and those are the corresponding values of y. So and these values of x and y for each of those columns, they correspond with the point that the graph makes along the Cartesian coordinates and the Euclidean plane. And when you join those points together, you are going to get the graphs, and that graph is the plotted graph of the equation. So now without wasting much time and without so I want to show and not just tell, and then we are going to make use of this equation. I'm going to use it to plot a graph, and then when I'm back, we are going to use that we are going to go on to derive an equation using a graph. So let's get. Hello everyone, this is Anthony Nathaniel here again, and in this particular episode we are going to be dealing with what we continued from. So we're going to continue from there, and then I talked about drawing the graph of y is equal to x squared plus x minus 5, right? So and then we are making use of the scale of 1 centimeter to 1 unit for both axes. So in that case, let's draw the axis. So now we are going to start from the y axis. For the y axis, we have the x, so we have this is 1 centimeter for 1 unit. This is 1 unit, and this is second unit. This is third unit. This is 4 units. 5 units, 6, 7, 8, 9, 10, 11, 12. So you can see that the y ranges from the highest value of y is 7 and the lowest value of y is -5. So you can see that when you look at the range of y is just from here to here. That it covers the entire graph. So that means we are going to have 7 boxes on the positive y axis. 1, 2, 3, 4, 5, 6, 7. So let's stop here. So we'll draw our x axis will be we'll start from here. So by knowing the y limits for both positive and negative axis, you can use that to plot your x axis, and then correspondingly you can also use your x limits to draw your y axis. So let me show you how. So our limits of x are, the upper limit is 3 and the lower limit is -4. So that means x will range from -4. So assuming you have -4 here, -4, -3, -2, -1, 0. So this axis, they cross at 0. That means our y axis will be drawn from this line. So and then we will also have it extended to 1, 2, and 3. So that is possible. So now let's draw this. Let's draw the starting from the lowest point. If possible, make use of a long ruler. So I'm just trying to sketch this and show you how it will look on average. So this is not really so now then let's draw this. This is the origin. So this origin represents the intersection of the axes. So let's call this this is the y-axis. This is the positive y-axis plus y. This is the negative y-axis minus y. Negative axis minus y. This is the positive x-axis plus x. Let's call it plus x. This negative x-axis. Let's call it sorry. This is a negative x-axis. This will be minus x, and then this is a positive x-axis. This is plus x. So since we're using a scale of 1 to 1 axis, so 1 to 1 unit, 1 centimeter to 1 unit. So this will be after this 1 unit to the left, that will be minus 1. The second unit, that was minus 2. Then again we have minus 3, minus 3, minus 3 here, and again we have minus 4, minus 4. Then on the positive axis of x, we have 1 plus 1 plus 2 plus 3. So I hope you can see these values. Then on the y-axis we have the positive value of y. That will be plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, and then lastly plus 7. And the negative y-axis we have minus 1, minus 2, minus 3, minus 4. Then finally we have minus 5. So I hope you are getting that. Then next, having drawn this, let's move on to plotting the value. So we have that when x is minus 4, y is 7. So that means when x is minus 4, you are going to use your ruler to trace minus 4 on the x-axis. This is the x-axis. So on this x-axis, we have minus 4. So this is minus 4. So when this is minus 4, we have a corresponding value of 7. So when this is minus 4, we trace minus 4 to 7 on the y-axis. So they will intersect at this point. Let's draw it as a circle. Like that. The next, when x is minus 3, y is 1. So let's trace minus 3 on the x-axis. That's minus 3. So this x, we'll trace it upwards. Let's just use you don't need to trace it with your pencil, just use your eye to trace it up. Then you now go to the y-axis. When x is minus 3, y is what? Y is 1. So minus 3 and 1. So where do they intersect? Minus 3 and 1. They intersect here. So you can see the gap from the first to the second. So that is often possible in quadratic graphs, because quadratic graphs, they are very, very large and they are parabolic in nature. So then when x is minus 2, y is minus 3. So when x is minus 2, we trace minus 2 on the x-axis. This horizontal axis is the x-axis. So x-axis, when x is minus 2, y is what? Y is minus 3. So minus 2 on the x-axis and minus 3 on the y-axis. Minus 2 on the x-axis and minus 3 on the y-axis. So where do they intersect? They intersect here. So this will be an intersection. We just represent it as a little circle. So then next we have when x is minus 1, y is minus 5. So we have minus 1 here on the x-axis, and then we have minus 5 on the y-axis here. So minus 5. So then we have when x is 0, y is 5. So when x is 0, y is sorry. When x is 0, y is minus 5. Okay, when x is 0, y is minus 5. So we still have 0 and minus 5. 0 minus 5. Then we have again when x is 1, y is minus 3. So when x is 1 on the x-axis and minus 3. So they intersect at this point. That's what is tiny circle. Then next we have when x is 2, y is 1. So when x is 2 on the x-axis, y is 1. That will be 2 and positive 1. That will be here. And next we have when x is, so I hope you are following. It's actually very simple. So all I need to do is just follow. Then when x is 3, what? Y is 7. This is the last point. When x is 3, y is 7. So we have the last 7. So you can see that this curve is actually symmetrical. So from 7 to 7 on the y-axis, from minus 4 to minus 3. So the next part of this question is to join your points. You can make use of your broom to join the points, or you can make use of a French curve. So because I know that I'm aware of the fact that most mathematics students do not have a French curve. It's only technical drawing students that often have French curves. So because of that, we are going to be making use of a broom in this video. But let me just let you know that personally, when I did my work, I made use of a French curve because I was also a technical drawing student, and I was quite apt in that direction. But for this video to be precise and to carry everyone along, we'll make use of a broom. So let's go on. Okay, now as a bonus tip to you guys out there, now before you draw your curve, you can use your pencil to lightly trace the possible parts of your curve. So as you can see, these are parts. Our curve will possibly trace this part. So the reason for this is to guide your broom, so that you don't go through the extremities of. So I'll just trace a possible part. So you can trace it free with your hand. Just trace it free with your hand, but make it very light. So you might not even be able to see it on the video now, because I'm making it very light. So this will be possible. Unfortunately, my graph has has extended beyond the axis, but I'll just you have to bear with me on that. So one of the mistakes students often make in graph is that we often make the wrong predictions with the extent of our graphs. So I didn't know that it's going to pass the axis. So and then we often make that mistake. So if you make that mistake often, so there's a solution to it which I'll talk about not in this mathematics course, but there's a solution to it which I'll talk about in the further mathematics course. So you just make use of your broom and then you trace along. So you make it as so I'm not very good with using this broom, but because when I wrote my examination, I made use of a French curve. But if you can make use of a French curve, fine. So at the end of the day, you will still need something straight to thicken the lines though. But the reason why broom is used is because broom is quite flexible and can go places. So then we have this next point. So let's join this next two points. So then we have this one. So as you can see, I'm joining the points. I'm also following the parts of the approximate parts that my freehand prescribed for me. So I'll follow this one. Then for this one that looks very tiny, this tiny curve, you could use your hand to sketch it in. Just carefully use your hand to sketch it in. So it won't be really noticed if you take it slowly. Then let's join the next two. So that will be, let's join them like this. Then the next point, let's join them. Just fix your hand on the 2 points, and then let your hand be sharp. Just let it go freely. That's how to make it a broom. Then the last 2 points, you just fix the hand on the last 2 points, and then let the hand go freely. So the broom will bend, and your line will follow the path. So after doing this, you can also thicken this line. You can thicken the line with your hands, but you must make sure you must be very slow and careful. So you must follow the line carefully. I'm even deviating from the line itself. So but just to make it thick and to make it visible to the examiner. So I'm doing this for the benefit of those of you who might be writing examinations like Quadratic, NECO, and so on and so forth. So you must make sure you follow the line carefully. Take it as slow. Nobody's trying to stop you. So just take it slow and take your time. In any examination, if you're writing an examination, take it slow. Take your time. Follow the curve carefully. So the essence of this is to thicken the line you've already drawn with your broom. So you don't need to be too perfect with it, but just make it thick enough to be visible. And actually, it's raining over here, so that's why this video might not be very audible. But you can see I'm also moving my hand as I'm drawing the curve. So this is the approximate curve, and then when you are done, you can name the curve. So this is the curve of y equals x squared plus x squared plus x minus 5. So then there are different things your examiner will consider when marking. For example, this contortion, this bending They will look for the bend and they look for shade in your curve. So make sure you watch out for those.